My purpose is that I will be passing in some file with a natural language prompt that could you please summarize whatever there in this particular image, or could you reduce the quality of this image, or could you improve the quality of this image, or could you please summarize this text, only the text, or could you compress this video. All of this thing can be done via LLM and tool calling in LangGraph. That is what I'm aiming for this. So, hello everyone, this is Deepak Joshi, and today we are going to learn about new things. The thing that we are going to learn in this particular video is LangGraph tool calling, and we will be building a small project on top of it that will be utilizing different tools through LLM and how LLM can execute those tools, and it can execute those tools sequentially as well. Like the output of one of the tool can be utilized as an input to another tool with some interference by LLM. That is how that is what we are going to look into this particular video, and we will be creating a small LangGraph graph as well, and we will be creating a FastAPI wrapper on top of that particular graph, and then we will be hitting it through Postman, or you can use Thunder client or whatever client you want to use. But like the goal of this particular video is just to understand how this tool calling works, because previously I made a video on MCPs. That was nothing. MCPs are nothing but tool calling, and resources are nothing but extracting things from some static server. That's how I'm seeing those things. But I felt like understanding MCP is important, but understanding how this tool calling is happening internally via cursor give us more context in understanding MCPs better, or any of the tool calling thing better, because nowadays LLMs are trained on the data that is not recent. What do I mean by recent? If I ask LLM to tell me the current weather, it will be not able to understand that, or it will be not able to cater me that particular response. Why? Because it is not trained on the present data. So how the LLM is going to respond to that particular thing is, we can create a function or a tool that will hit the API to get the recent weather details, and then LLM will understand that API response, and then will give me a response based on the natural language, like, hey Deepak, this is the current temperature where you live. So this something like this. Tools can be anything. Tools are generally functions which an LLM can execute. Okay. So what we are going to do in this particular lecture is, we will be creating, like I was very much interested in how OCRs works, like how image to text is happening. I tried different models, but then I but I then landed on something which to set it up, we do not have to set our environments or something like that. Like to use OCR tools are something that extracts text from the images. You have to set things up in your environment, or wire up a model locally, but that is something that I didn't wanted to teach here. That is something you can explore by yourself. I landed on a library that is EasyOCR. So you just have to do pip install EasyOCR, and it will set up everything for you. There is a drawback of it that it with every run of the server it does the same thing, but there is caching involved in it. So but it's good for learning. That's what my purpose is, that I will be passing in some file with a natural language prompt that could you please summarize whatever there in this particular image, or could you reduce the quality of this image, or could you improve the quality of this image, or could you please summarize this text, only the text, or could you compress this video. All of this thing can be done via LLM and tool calling in LangGraph. That is what I'm aiming for this lecture. I will be not building all the tools over here. Honestly, I will be pushing the code to my GitHub repository, and you can take a look over there. I will be explaining some of the tools that you can understand, okay, how this thing is working, and then you can expand your LLM. Let's start with a fresh project. I have named it as tool calling. I have my .env. I'm not going to open this, honestly. Yeah, of course. Yeah, and to initiate this, you need an OpenAPI key. I'm using OpenAPI key. You can use any of the model. That's completely fine. You just have to configure that in your .env with an OpenAPI key key, and the value should be your OpenAPI key. All right, and post that, what you have to do is you have to initiate your environment. I don't even remember how to initiate. So what I am going to do is, please give me the command. Give me the command if it is there. Yeah, here is the command that you can use to initiate a Python environment. Python -mvenv, and then the name of your Python environment. I'm just keeping it as venv. It should create my Python environment. Then there is a scripts folder. Let it just finish, then I'll look into it. Yeah, so here is my venv, and then there is the script folder that contains activate.ps1. so I have to hit this particular one to activate my environment variable. That is the command. Go into venv scripts and then this activate.ps1. so it will be able to activate your command. Now my Python environment is activated. What is PS1? PlayStation 1. But I like PS5. Yes, that is something okay. Now we will be requiring some of the libraries that that we will be utilizing. So to utilize those, I will be creating a requirements.txt. So for those of you who are very new to Python, think of requirements.txt as package.json in Node.js, or yeah, in Node.js. Like, it will contain all the libraries with or without their versions that you need to run this particular project. Okay, so I have this list of libraries. EasyOCR is also there. And now to install every package in my environment, what I'll be doing is I'll be doing pip install -r new keyboard requirements.txt. Yeah, I just clicked on tab, that's why. So it is just installing everything up. It will take time, and till it is happening, what we can do is we can start our coding and we can implement the things. I'll be creating a src folder. In this initially what we need is we need to set up our config file. Okay, so I'll be first creating a config.py. Yeah, in this, what do I need? I need to set up what image types I'm going to support, what audio types I'm going to support, what video types I'm going to support, the temporary directory that I will be utilizing, because the FastAPI will be giving me the files, and then I have to store them temporarily, and then I have to, like, all the hard-coded things that I need to be configuring it from here. So what do I need? First of all, there's from .env. It's env. Okay, import load env. What is this? It is it will be helpful for us to extract the OpenAPI key that is present in my .env file, and then I can utilize it from here. Yeah, that is something that we can and then I have to load it. So that is how you load it. And just do OpenAPI key equals to os.getenv. Now what is OS? OS is operating system, so you have to import OS as well. Cool, makes sense. So I guess, yeah, it's still happening. We were able to understand these 5 pieces of line or 4 pieces of line. Now we will be defining a class config. That will be oops object-oriented programming. Now in this, we have to define our supported image types, supported audio types, and like, I am good at it, so I'll be just doing copy and paste. For now, supported image files are JPG, JP, GPNG, BMP, and supported audio files are MP3, WAV, and M4A. Supported video types are MP4, AV1, and MOV. Okay, and then we will then we have to decide our, like, set up our temp directories and output directories, but it says there is no path. So what we are going to do is we are going to do an import from pathlib import path. Simple. There it should be gone. Yeah, but what if the temp dir and output dir are not there? Then we will be creating those. Simple. Okay. Yes. Do we need parents too? We can keep this. Yeah. So we have created our config file. Let me check whether no. We are still installing our we are still doing pip install. That's completely fine. So we were able to come up with our config file that contains that gives us the OpenAPI key, that gives us the supported image types, that audio types, video types, and the temporary directory along with the output directory. That makes complete sense. Okay, now we have to now what we can do is we can create our tool. I will be creating a simple tool, but to do that, I just want that the structure of all of my tools should be same. That's why I'm keeping a base tool that will utilize the LangChain base tool. That will be inheriting LangChain base tool. Okay, so that's the structure that I'm planning to have for my tools, is that they will have tools will have an init and asynchronous run and a synchronous run function, these three things, and the output of all these three, like init function will not have any return thing, but the asynchronous run and the synchronous run should return strings, because what I want is my tools output can be utilized by LLM as well. Okay, and it is very simple for LLMs to understand string as compared to other data types. Cool, it makes sense. So what I'm going to do is I'm going to define a class base tool. Class base tool, yes. In that class base tool, so this class base tool will be inheriting LangChain base tool, if I'm not wrong, and ABC. Okay. Please. Let me see if it is done. No, it's not done. Let's do one thing. Okay, I thought I lost my cursor as in the real cursor. Okay, let's do one thing. I'm just loading something. I just want to make sure that okay, so yeah, let's see if it, no, I was still waiting for that. Now we are going to create a, like, as we discussed that I'm going to create a base tool. That what is this base tool? This base tool is a sort of abstract class. What is an abstract class, Deepak? So as far as I know, abstract classes are those classes which cannot be instantiated directly. You cannot create object of an abstract class directly. You can inherit them first and then override their functions and then create the objects of those classes. Pretty simple. I guess I was able to explain what is an abstract class. Let's say you have a an abstract class A. Now you cannot create object of A, but what you can do is you can create child B from A, and then you can create object of B. Simple. That's how abstract classes works. So I'm creating a class base tool that is for now inheriting LangChain base tool. From where it is coming from? It is coming from langchain.co.tools. langchain.co.tools import base tool. That's completely fine. You can keep it as base tool as well. You don't need to, or for better naming, I can just keep it as LangChain base tool. Makes sense. I'm importing abstract classes from ABC. Makes sense. Now my name for this, like, the tools will have two things: the name of the tool and the description, so that LLM can pick it up more easily. The second thing is description. Okay, yeah, so the description will be also a string. Now I'm just defining an init function for it. It will have self and the k-args and the k-args, that is the knowledge arguments that will be coming from the LLMs. It will be initializing the init method of the super, that is LangChain base tools, k-args and the abstract class, and we will be just logging tool self.name initiated. Or yeah, makes sense. Pretty simple and sweet. But how are you using logger, Deepak, here? So I will be saying that we have loguru is the thing we did in our pip install. Yeah, it was able to come up with pip install. Nice. Now we will have our abstract method that will be async diff and it will be a run is asynchronous run. it will contain self and the input. That will be a string. Simple. And we can pass in a comment, or we can just pass, like it will be this abstract method will this abstract method will be implemented in our tools, in our actual tools, which we will be implementing. Simple. Now there will be a synchronous one as well. That will be self input str, and it will be returning an str. So as of now, I'm not planning to support synchronous run. So I will be just raising a not implemented error. Not implemented error. Simple. This method should be implemented by the subclass or something, like, or only async methods are supported for now. I'm not implementing the synchronous runs. I'm just including the asynchronous run. So my base class is ready. What's this error? It says undefined name abstract method. Okay, that is something new. You can just, oh, okay, that is something new. Is it because this? Yeah, makes sense. Now we have come up with our base tool. That is something nice. Now what I am planning to do with this base abstract class is we will be utilizing this as our base class, and then on top of it we will be implementing all of our tool. The first tool that I want to implement is OCR tool, because I not PU, please, it will be PY. Okay, so first of all, I was talking about OCRs, and the library that I landed on is EasyOCR. This is the one. We will be utilizing this, and also we will be utilizing our base class, that is base tool, and we need our log guru to log things up. Do we need anything else? We need something else as well, but we'll come to it. We'll create our OCR tool that will be inheriting our base tool. The name of it will be OCR tool, or let's just keep it as OCR. We need a description for it. So for the description, I'll be just writing this description: extracts text from images using EasyOCR. Simple. And there will be a reader class. For this I have to import class. Okay, let's do that. Let's do it. From typing I need class var. Simple. For now we'll keep it as none. Makes sense. Now we need to define two things, right? The init method and the asynchronous run. So for init, what I need, what I'll be expecting, I will be expecting a self, because that was the base class definition, right? And the knowledge args, AW args, right? Makes sense. What it will do, it will do super init k args, and if oh, okay, that is self dot reader, as that is also fine. Makes sense. Yeah, it makes sense to do this. Or what we can do is we can do this as well, OCR dot reader. Yeah, that is also fine. Now in our asynchronous run, what we will do is we will have our error handling try. What we will do is we will store our results from OCR tool, like OCR tool dot reader dot, did I wrote it correctly? Yeah, read text. There is a function called read text which will read the text from input. Makes sense. For now it takes what does it takes? It's loading. Okay, I cannot go into its definition somehow, but makes sense. Yeah, there is an option that you can pass in as detail, which I can set to 0 for now. Okay, now we have the text. Just split that text up on the basis of this. I'll just keep it as results. Makes sense. And I'll extract a text from image. That's it. And then we will be returning our text dot, like stripe is something that we will use to remove all the extra blank spaces. And then if there is an exception happens, just print that up. Error extracting text from images. I guess I was able to explain. We were able to create one tool. It's one of the tool that LLM can utilize. Okay. So now we have our OCR tool. What we can do is we can just start working on our graph. Our graph will be pretty simple, very easy to implement, honestly. I just want to make sure that I'm in SRC. Let's create our graph. Graph.py. Okay. Now we have our graph. What do we need from our in our graph? We need LangChain agents. LangChain.agents. Import agent executor. We need create OpenAPI tools agent. Yeah, we need LangChain core dot prompts. From that we need chat prompt template, right? And we need message placeholder. That's it. And from LangChain OpenAPI we need of course OpenAPI, chat OpenAPI, LangChain OpenAI. We need import chat. Yeah, you were right. The suggestions are good from Cursor. And we need our loguru import logger. And we can import our tool as well from tools dot OCR tools import tools. Yeah, that makes sense for now. Okay, now let's implement our media processing graph. Okay, that is what I am calling it right now, processing graph. Okay, what it will have an init method. What this init method will do, it will have, all right, this is something nice. I don't want to use GPT-4 Omni. I just want to use GPT-4 Turbo Preview for now. Let's keep the temperature as 0. We have initialized our LLM. Now we can initialize our tools as well. So right now we have we only have our OCR tool, right? Where is our OCR tool? Yeah, yeah, we have our OCR tool right now. So like what you can do is you can create multiple tools and keep coming here and add those tools here. This will tell LLM, okay, these are the tools that I have. Like for now it is just an array in our graph, but I will tell you how we can make the LLM aware of this. We'll create a prompt. I'm just doing it all over here. You can create separate files. That is something for you to explore. Yeah, that is nice. I just want to copy my existing prompts, guys, because we will have multiple tools. I'm just making like mentioning those tools here. You are a media processing assistant. You have access to the following tools: OCR, transcriber, video compressor, image compressor, enhancer, LLM summarizer. Use them as needed to fulfill the user's instruction. Okay, makes sense. Then there is a human input and the message placeholder. I guess I was able to tell you what it looks like. Now we have to create our agent. Nice suggestion, guys. Nice suggestion. That this is how you create your OpenAPI tool agent. You provide the LLM, you provide the tools, and you provide the prompt. Now you have successfully created your agent. Yay! You have created your agent. Now you have to create your agent executor as well. That is how you create your agent executor. That it gives LLM an autonomous power to execute tools by itself. You do not have to manually read the KW args coming in the OpenAPI response and then extract the function arguments from it and then pass it to the function. No, you do not have to. LLM will take care of it. Okay. Yeah. We will be passing self.agent tools and the verbose true. That makes sense. Verbose is nothing but for logging. Makes sense. Now we will have our async defined, like function defined, asynchronous function defined for processing media. What it will do is it will have user input. We want a lot of things actually from the FastAPI. We will be creating the FastAPI and it will not be returning str. It will be returning a dictionary. Okay, these are the things that we will be expecting: instruction, file path, and file type. That is file type. Okay, Yeah, and then what we will be doing with this information is we will be creating a user prompt, the initial instruction, then the file path and the file type. And then we will be executing or like invoking our agent executor. The agent will return us the result and then give us the result, and then we will be returning status success result get output. That's fine. That's completely fine. Yeah. Now that we have our graph ready, it's a very simple and sweet thing. Like we are just calling our agent executor. Now, what we need to do is I'll be not going into much details of our fast API wrapper, or I can go into that. Let's do one thing. Let's create our fast API wrapper. That will be main.py. This is what it looks like. I mean, I'm initiating a fast API app. Like this is simple, my main processing graph object. Okay. Now, here there is a route that is process. It takes a file and instruction. Now I'm extracting the file path with a write and binary format. Yeah, and then I'm copying it into file.file. Okay, this file.file is coming from yeah, just give me a second. Yeah, file path is over here, and then we are writing this thing over here as a buffer, and then we are copying the objects, okay, of the buffer into our file.file path. Yeah, that's what I was talking about. Now there's a meme type that like expecting, and we are file type is the extension. So meme type is something that that is very different from the extensions, because some for example, this is a meme type application slash octet dot stream. There are another meme type as well, mime type or something like that, that is application slash CSV, or there are libraries that help you get the mime types. So this is what we utilized over here, mime types. Yeah, now we are calling our process media with the instruction, file path and file type, and simply returning the JSON response to the client. If there is an exception handled, do this. And finally, in both the cases, if we were able to return the response or not, we are just deleting, unlinking everything. Simple, just to make sure that our output does not contain anything else. Okay, that's the one thing. I guess our graph, our main.py is ready. We can run this up. I don't remember what the command was to run this, but that's fine. Yeah, let's run this and see if we were able to come up with a thing. Okay. Seems like it's running right now. Okay. It will take time. It will take time because the OCR thing will load. Yeah. So neither CUDA or MPS are available, defaulting to CPU node. This model is much faster with a GPU. Makes sense. Initially, if you run this OCR tool, then it will download something. So that's fine. Now you just have to open your Postman. Aha. Okay. My Postman is running. It's running. It's pretty fast. Yeah, I am able to open my Postman. So these are the configuration that I need. Like you have to set your request as post, and then the route should be something like this. go into body and then form data. Here select file, like here select file, name the key as file, upload the file with the instruction, and the another key should be instruction. And this is not something, this is not the tool that we have created. What is there in, what is the text present in, like a prompt, what is the text present in this image? So just simply just like this, I'm moving it to another place so that we can look into our terminal. Okay, now I'm going to click on send. Let's see what happens. Let's see. Excited? I've clicked on send and it shows sending request. Oh, std out callback handler dot on chain starter callback attribute none type object has no attribute get. You can take a look into that particular error. I'm not going to take a look into that because it is able to invoke the OCR tool with the input, the path. Like it, what it did is it created a temporary directory and stored the input file into that. There has to be a temporary directory. Yeah, this was the image. Pretty image. It's loading them. Like this is the image that I passed in. He codes to a point where he writes too many bugs and then blames it on his compiler. He's you. And it was able to extract the things. Now let's see what our postman has. Yeah, our postman, like our status, our instruction was what is the text present in the image. The text present in the image is the LLM responded. Geeks for geeks. He codes to a point where he writes too many bugs and then blames it on his compiler. He's you. So what's the process? What the process was, I passed in a file and an instruction. It went to my LangGraph graph. Then it utilized agent executor that has the agent, the tools, and the prompt. Now the agent decided, okay, I need this is an image, I need to extract the data text from this particular image, then only I will be able to cater the user instruction. So it ran my OCR tool and then extracted the output from it and then processed it again, the output, and then returned me this result, the text present in the image. Like, isn't it beautiful? You can create multiple tools. I can show you the repository that I have. Let's just get rid of this. Yeah, and here it is. So these are the tools that you can create. There is an image compressor tool that I created. There is an enhancer tool that I created. LLM summarizer tool that I created. For think of chaining. It can, the structure that we have created previously on that particular project is capable of chaining as well. You can pass in multiple requests. For example, I have this LLM summarizer tool and the OCR tool. You can write an instruction as, hey, could you please extract the data for text from this image and then create a summary of it. It will be able to extract, first call the OCR tool and then synchronously call the next tool with the output of the OCR tool, and it will be able to give you the summary. That's the beauty of the agent execution. So I have this LLM summarizer, the OCR tool we created together, and this transcriber tool which uses Whisper, and the video compressor tool. So I'll be pushing all the things to where GitHub. There you can take a look and tell me how it went. Hope I was able to explain you the things like how the agent execution work and how LLMs execute tools. Let me know if there is anything that I should be building next for you, or if there is any doubt that I can resolve, or if there is anything that I can contribute to. Thanks. Bye bye. Take care.